Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, mole concept. Come on, let us discuss few more questions from this session. Here, the first question, 342 gram of 20% by mass of barium hydroxide solution, specific gravity 0.57 s, reacted with 1200 ml of 2M-HNO3. If the final density of solution is same as pure water, then molarity of the solution, that is molarity of the ion in the resulting solution, which decides the nature of the above solution. So here acid and base reactions taking place. In that we have to identify what it is, nature of the solution. So nature of the solution decided by what it is, molarity of the ion. So hydroxyl and H plus ion. So let us identify the number of moles. Then we can identify what it is, limiting reagent and excess reagent. From that we can identify the resulting solution of the nature. Come on, let us check. So first and foremost, the given mass, how much they have mentioned, 342 gram of 20% by mass. So mass of barium hydroxide, mass of barium hydroxide. So mass of barium hydroxide means it is a given mass only. So how much they have given? That is 20% of what it is, 20% of 342 gram. So how do we get that given mass? In that mass, that is total mass into percentage. Total mass into percentage. Total mass how much? It is 342 gram. Into percentage how much? 20% now. So we can take it as 0.20. So how much percentage it will be? It will be around 68.4 gram, right? So given mass of barium hydroxide, at a 68.4 gram. Okay, given mass we found. Now, molar mass of barium hydroxide. Usually they will give in the question only, but sometimes we have to identify. So, molar mass of barium hydroxide, BaOH twice. That is actually what it is, 171 gram per mole. Right, now here, a number of moles of barium hydroxide. Number of moles of barium hydroxide, BaOH twice. So how much you will get? Given mass by molecular mass, no? Given mass by molar mass, right? So given mass how much? It is 68, right? So 68.4 gram divided by molar mass 171 gram per mole. So how much you will be getting? Gram and gram will be cancelled. So you will be getting around 0.4 moles. Right, so number of moles of barium hydroxide, it is actually what it is, number of moles. Okay, number of moles of barium hydroxide, BaOH twice, that is 0.4 moles. Right, now here when you go for this BaOH twice, so you will get 2 OH minus ions, right? Ions only we have to consider here because they are asking in the question number of ions only, right? Okay, so total moles of the barium hydroxide, total moles of barium hydroxide. So moles of barium hydroxide, that is this one, moles of barium hydroxide plus, no, this you have to multiply. So multiply with that, what it is, number of ions, number of OH minus ions, right? So that means here what it is, here 0.4 moles, right? And this is 2 number of OH minus ions. So 0.4 into 0.2. So you will be getting 0.8 moles altogether, total moles of BaOH twice, right? Okay, we got it. Now HNO3, now we have to find out that HNO3, now first one we found what it is, BaOH twice, and now we have to identify acid. Okay, so here volume how much? It is 1200 ml, right? And 2m HNO3, here HNO3, right? Okay, now moles of H plus ion, moles of H plus ions. Moles of H plus ion equal to molarity into volume in liter of the solution. So molarity, it is actually 2m. in the question only they mentioned. Into volume in liter, how do we write it? It is a ml. We just converted into liter. So that is 1.2 liter. So that means here, what is the answer? You will be getting number of moles of H plus ion. Moles of H plus ion, it is 2.4 moles. Right. So here, neutralization reaction. So this is number of moles of, actually what it is, H plus ion, number of moles of OH minus ions. So neutralization reaction, acid and base, it is neutralized, right? So neutralization reaction, So each moles we just identify. So here H plus ion plus OH minus ion. So H plus ion, just now we mentioned what it is, 2.4 moles. Right. And OH minus ions, it is not addition, just H plus and OH minus, it is a neutralization. So 2.4 moles and what it is, 0.8 moles. So you will get confused. I just about this point. Okay. So this is H plus ions. So this is actually what it is, H plus ions. And this is OH minus ions. Right. So how many moles each? I think I just mentioned. Now we have to identify which is the limiting reagent. So naturally OH minus ions on this have actually limiting reagent. So this is limiting reagent. Right. Now this is excess reagent. Excess. Right. Now next one what we have to identify, from that excess reagent we have to minus that OH minus ion. So you will get that resulting solution. So here H plus ion, OH minus ion. So whether this solution is acidic or basic, we can identify through what it is, the solution. The resulting solution, I just put it, the resulting solution. The resulting solution. The resulting solution, it is what it is. Now 2.4 moles minus 0.8 moles. So you will get what it is, 1.6 moles. So 1.6 moles extra H plus ion, it is available. So generally acid and base, it gives salt and water. It has to be equal both. So that means which is excess, 2.4 moles excess. So from that excess, if it is 0.8 moles relieved, means remaining how much, 1.6 moles will be extra. So 1.6 moles excess means that is what it is, acidic in nature, right? Because H plus ion, it is remaining. So the solution, resulting solution is acidic in nature. Acidic in nature. I hope you got the clarity. Yes. Okay. Now we have to identify another step. What it is, final volume of that specific gravity they mentioned, right? Now final volume of barium hydroxide. Okay. So final volume of barium hydroxide. Final volume of barium hydroxide. In the question, specific gravity they mentioned, so that is 0.57. So density, this is actually what it is, density equal to mass by volume, right? Density equal to mass by volume. Right now here, volume of BaOH, volume of BaOH twice, that is 342 divided by mass of that barium hydroxide, so 342 divided by 0.57. So you will get what it is, 600 ml. Right. Now here, volume of BaOH only, right? Now this is volume of HNO3. Volume of HNO3, how much it is? 1200 ml they mentioned in the question only. Right. Now both total volume, this and this. Okay. So this and this total volume. Total volume, it is 600 plus 1200. So both together how much? 1800 ml. Right. So 1800 ml we can convert it into liter, 1.8 liter. Right. Total volume. Now number of moles also we found it, and volume of solution in liter also we found it. Finally, what is that main point? Molarity only. What is it, molarity? Molarity. So molarity, it is number of moles divided by volume of solution in liter, right? So here excess moles we have to check. Excess moles divided by volume in solution. Volume in solution in liter. So excess moles, how much we found? It is 1.6 moles, right? Divided by volume in solution, 1.8 liter, right? This is moles. This is liter. So when you calculate it, you will get 0.888 molarity. Molarity also we can write it, or moles per liter. This is mole per liter, right? Mole per liter also we can write it. So molarity of here H plus ions only decides the what it is, the resulting solution, nature of the solution, due to that excess of the reagent. Which is that excess of the reagent? H plus ions only. So the resulting solution, it is 0.888 molarity, and the resulting solution, it is acidic in nature. So H plus ion. Right, I hope you got the clarity. How do we identify? So finally, we are coming to that conclusion through what it is. Density, what specific gravity they have given. Now, through that, we are finding out that molarity. Now, I hope you got that clarity about this question. Yes, which is the correct option? Option C, 0.888 molarity is the correct option according to this data from this question. Come on, let's go to the next question. Here, the next question. Here, 100 ml of H2SO4 solution having molarity 1 m and density 1.5 gram per ml is mixed with 400 ml of water. Calculate final molarity of H2SO4 solution if final density is 1.25 gram per ml. Right. Now, here, volume of solution they have provided, molarity also they have given. So, number of moles we have to identify. Right now, let me write the data first for you to understand. So, volume of the solution. Volume how much? 100 ml. Right now here molarity how much? It is 1 m. So we are talking about what it is? H2SO4 only. H2SO4 only. Right now here number of moles. So number of moles of H2SO4. So volume, it is number of moles. How do we identify? Molarity into volume of solution in liter, right? So molarity how much? 1 m, and volume of solution, it is 100 ml. So 100 ml volume in liter, 0.1 liter, right? So 0.1 liter. So when we calculate it, so number of moles how much? 0.1 mole, right? So number of moles of H2SO4, that is 0.1. Now mass of acid solution, here specific gravity there, density they have provided, right? So density it is 1.5. So mass of acid solution. So mass of acid solution. It is density equal to mass by volume, right? Now mass we can bring it volume into density. Volume into density, it is 100 ml, and density it is 1.5 gram per ml. Right, now we can convert mass of the solution. So how much you will be getting? 150 gram. So this gram and this gram will be cancelled. Sorry, this ml and this ml will be cancelled. 150 gram, right? Okay, now mass of acid only. So the mass of acid solution. Mass of H2SO4 solution. Right, I hope you got that idea. Now, next one, mass of water. Now the next one, what it is? Mass of water. So mass of water, what it is? Here volume into density only now. Volume into density. So volume it is 400 ml. In the question it has mentioned volume of water it is 400 ml. And density of water. So density they did not mention. But generally pure water density. Pure water density. Density it is exactly 1. Exactly. 1 gram per ml, right? So this is 1 gram per ml. Right now mass of water, what it is? This ml and ml will be cancelled, right? Now how much it is? Mass of water, it is 400 gram, right? 400 gram. Now the total mass of volume of mass of acid solution and mass of water. So total mass. How much total mass? Total mass how much? 400 plus this is and that is 550, right? That is 150. Yeah, this is 150 and that is 400, no? 150 gram both. So you will get what it is? 550 gram. Right. Now final volume they mentioned, you know. So final volume, what it is? Final volume. So final volume, it is actually density. Final density also they mentioned, right? Final density they mention, no? So final density, how do we go for it? Okay, now final density density. So final density, it is 1.25 gram per ml. Right. Now here final volume, it is actually final volume, it is total mass divided by final density. Right. So you will get how much when you can apply this value. Here total mass, it is 550 gram divided by final density 1.25 gram per ml. Right now here volume only now, so gram and gram will be cancelled anyway. Final volume only, no ml it is there. So when you calculate it, you will get how much? 440 ml you will be getting. Volume of solution in liter, you have to convert it into liter. So volume of solution in liter. Right. So how much it is? 440 divided by 1000. So you will get 0.44 liter. Right. Now here molarity we have to identify finally. What is it? Molarity, it is number of solution, moles by volume in liter. So moles by volume in liter. Right now moles, how much? It is 0.1 mole. The first starting number of moles we found, no answer. Here number of moles we found, no, that point number of moles divided by volume of solution in liter. Volume of solution in liter, how much? 0.44 liter. So you will get what it is? 0.227 molarity. Right. Now here molarity of H2SO4 solution. Molarity of H2SO4 solution. How much? 0.227 m. Right. I hope you got the clarity. How do we identify? This question answer a little bit lengthier, but still you have to understand now. That is what I elaborated and I've explained each and every point. So which is the correct option? Option D is the correct option. I hope you got the clarity about this question. Come on, let's go to the next question. The next question, what volume of HCl solution of density 1.2 grams centimeter cube and containing 36.5% by mass of HCl must be allowed to react with zinc in order to liberate 4 gram of hydrogen? See, zinc plus HCl, that means metal plus acid, you will get hydrogen liberating. That 100% you know very well. Okay, come on, let us go for to deal this question. So zinc plus HCl, you will get zinc chloride ZnCl2 plus H2. So here 2, so naturally here 2. So 2 moles of HCl combined with the zinc, you will get 1 mole of hydrogen. Yeah, from here only we can identify the answer according to that question. So easily we can identify. So 2 moles of HCl require to liberate actually 1 mole of hydrogen, 1 mole of hydrogen gas. Right. Okay. Now here a number of moles of HCl, number of moles of HCl, it is 2, right? Moles of hydrogen gas. Okay, so given mass, it is actually, they have mentioned it is 4 gram. Molar mass of hydrogen, it is 2. So number of moles of hydrogen. Okay, given mass of hydrogen, it is 4 gram. Right, molar mass of hydrogen, you know very well, that is here 2, no, so naturally here also 2. Okay, molar mass 2 only, 2 gram per mole. Right now here number of moles of hydrogen, so here given mass by molar mass. Right now here given mass 4 gram, molar mass it's 2 gram per mole. Right now here you will get how much? Here 2 moles, right? 2 moles, number of moles of hydrogen gas, it is 2 moles. Now this balanced equation we identified. No, what is that balanced equation? Zn plus 2 HCl, it gives ZnCl2 plus H2. So from this balanced equation, the ratio it is 2:1. So 2 moles of HCl require 1 mole of H2. Right. So moles of HCl we have to identify. Right now moles of HCl. So 2 into moles of hydrogen. Moles of hydrogen. So here number of moles, here balanced equation, according to balanced equation, it is 2 moles of HCl required to liberate 1 mole of hydrogen. And here in that, well, calculating, we are getting it's 2. So altogether it is 2 into 2, you will get what it is? 4 moles. So 4 moles of HCl, we got it. Okay, now here mass of pure HCl. Right now, next one, what it is? Mass of pure HCl. Mass of pure HCl. So mass of pure HCl, that is given mass only we have to identify. So given mass, for that, what is the formula you will be using? Moles into molar mass. Moles into molar mass. Moles, how much it is? Moles of HCl only, right? Of course. HCl only, both. Right now, here moles, how much we identified? It is 4 moles into molar mass of HCl. This is, you know, very well. Universal dialogue, that is 36.5 gram per mole. So HCl, it is known very well. Molar mass of HCl, it is 36.5. Molar mass of H2SO4, it is 98. Molar mass of water, it is 18. So these are all a number of times we are using. So we know very well. So what is the answer you will be getting? So you'll be getting around 146 gram. See here, mass of pure HCl. So this is, actually this is mole, no. This is mole and mole, this will be cancelled. Mole and this mole. So the given mass, this is given mass. Given mass, no. So 146 pure mass of HCl, we got it. Okay, now next to one, mass of the solution. Mass of the solution. Mass of the solution. Mass of the solution, how much? Mass of pure HCl. Mass of pure HCl divided by percentage by mass of HCl. Percentage by mass of what it is? HCl. So you will get what it is? 146, no? 146 gram divided by percentage mass. Here percentage mass in the question, how much they have given? 36.5 they mentioned, you know. See here. 36.5. So 36.5 percentage, if we remove that percentage, how much it will be? 0.365, right? 365 gram, right? This is also gram only. So mass means gram only, right? So here what it is? You will get how much? 400 gram. 400 gram, right? Now here, density of the solution. So they asked about density. So density equal to what it is? Density equal to mass by volume, right? Volume equal to mass of the solution, mass by density. Density. So here mass of the solution, just now we found, no. So what is it? Mass of the solution, it is 400 gram, and this is 400 gram, right? Mass of the solution, this is 400, right? And the density they have given in the question, 1.2 gram per centimeter cube. See, in the question only they have mentioned, see, density 1.2 centimeter cube. Okay, so you will get around, you'll get how much? 333.33 centimeter cube. So the volume of the solution required to react with the zinc and liberate hydrogen, how much volume it is required? This is volume of the solution required. So it is 333.33 centimeter cube required. Centimeter cube, it is nothing, ml only, right? So how much it is actually? 333.33. So here ml only I just mentioned, no. See the answer, it is here. I hope you got the clarity. Now which is the correct option? Option A is the correct option. I hope you got an idea how to solve this question. Come on, let's go to the next question. An ideal gaseous mixture of ethane, that is C2H6, and ethene, C2H4, occupies 28 liter at 1 atmospheric pressure and 273 Kelvin. The mixture reacts completely with 128 gram of oxygen to produce carbon dioxide and water. Mole fraction at C2H6 in the mixture is. Yeah, come on, let us identify the answer, how to deal this question. Here gaseous mixture they mention, no. So let us use the ideal gas equation. What is the ideal gas equation? Ideal gas equation. Ideal gas equation, PV equal to nRT. So PV equal to nRT. Here pressure, how much they have given? Pressure, it is 1 atmospheric pressure, and temperature it is 273 Kelvin. Right now here volume how much? Here 28 liter, it has mentioned, right? 28 liter. See here 28 liter, and R gaseous constant R equal to 0.0821 what it is liter into atmospheric pressure per Kelvin per mole. Right, now here number of moles let us identify. So PV equal to nRT, no? So let us apply the values here. Number of moles N equal to PV by RT, right? So P 1 atmospheric pressure, volume it is 28 liter divided by R 0.0821 into temperature 273 Kelvin. Right, now here what is the answer you will get when you calculate this? Here you will get 1.25 moles. Right, when you calculate all this you will get this. Right, now the mixture reacts with 128 gram of oxygen. See here 128, see 128 gram of oxygen. So the mixture reacts with 128 gram of oxygen. Molar. Okay, now the same idea we can apply over here. The mixture reacts with 128 gram of oxygen. So molar mass of oxygen you know very well, 32 gram per mole. So number of moles of oxygen easily we can identify. Number of moles of oxygen. Here what it is, given mass by molar mass. Right, now here what it is, 128 gram divided by molar mass 32 gram per mole. Right, now gram will be cancelled. So number of moles how much? Here 4 moles. Right, now let us identify ethane and ethene, how much it has taken according to the mole fraction. So let us assume X and Y. So ethane C2H6. So this we can take it X, and ethene ENE, that is C2H4. Right, this is Y we have taken, and it reacts with oxygen combustion, right? Okay, C2H6 means ethane. Combined with oxygen, you will get carbon dioxide and water only, right? So CO2 plus H2O. So you will get what it is here. CO2 and H2O means here 2 is there, so naturally you will get 2. So here oxygen it is there. Here how many oxygen? Here 4 plus 1, 5 is there, no? So that means 3.5. So you will get 3 water molecules. So 3 2s are 6. Hydrogen is there, no? Right, now next one, and the same way ethene. This is ethane, and this is ethene. C2H4 plus oxygen. You will get how much? CO2 plus H2O. This also CO2 H2O, but balanced the same. 2 means here also 2, and here oxygen, here 3, and here also, here it is what it is 2. Hydrogen 2, oxygen here here 4 plus 2, 6. Yes, we got it. Right, now let us check the total moles of oxygen consumed for this both the reaction. Total moles of oxygen consumed. So both the reaction how much, let us check. So the reaction, I mean first equation, X plus Y equal to 1.25 moles. How do we get this 1.25 moles? See here we have calculated no PV equal to nRT gaseous reaction. So we collected all the data, and we what it is number of moles of N, 2.5 moles we calculated. No, that one we can take it as a first equation. And second equation, this both the equation how much oxygen consumed, that one we can take it. Okay, so here what it is, first one X it is 3.5 X 3.5 X plus 3 Y equal to how many moles here? Here how many moles for this? 4 moles. Right, 4 moles. I hope you got that idea. How do we identify? So this is equation 1 and this is equation 2. Right, now we have to balance. For that, multiply the first equation with the 3. So this is the first equation, multiply with the 3. Why? To balance that, okay, with the second equation. So multiply with the 3 means here what you will get it, 3x plus 3y equal to how much you will get? 3.75, no, 3.75 moles. Okay, then second equation you just apply. Second equation what it is? This one, no, second equation. So here 3.5x plus 3y equal to how much? 4 moles. So you can directly also, because this is a bigger number and smaller number, no? So in that way. Right, now when we calculate this, So this and this will be cancelled. Right now that is 0.5x equal to how much? It is 0.25 moles. So x equal to 0.5, right? So yeah, 5, now we have to identify that x 0.5x equal to this much. Okay, that means x equal to, so here how 0.25 divided by 0.5. So you will get what it is, 0.5 moles you will be getting, right? So now here substitute this value. Which value? X value, what it is? X equal to 0.5 moles. You got it. Right now, why you have to identify? For that, you have to substitute this value to equation 1. Substitute equation 1. So, x plus y. X plus y equal to 1.25. No, x how much is 0.5 plus y just, and you will get what it is, 1.25 only. Right now here, y, you just bring it out. Y equal to 1.25 minus 0.5. So you will get around y equal to 0.75 moles. I hope you got that clarity. It is going around the neck, but it is easy and simple because this is mole fraction. Mole fraction, both the compounds when we add, you will get one only. For that one, we have to go around the neck for the only one head, right? Okay, right now here mole fraction. Mole fraction. So mole fraction of ethane and ethene. Let us identify mole fraction of ethane, right? Mole fraction of ethane, right? C2H6. So what is the mole? How much we identify? 0.5. That is x right now. So 0.5 divided by 1.25. So you will get how much? 0.4 of ethane. Then remaining ethene, mole fraction of ethene, just 1 minus 0.4. So generally mole fraction, both the compounds combined together, you will get the answer 1 only. So mole fraction of ethene, C2H4. So you will get how much? Here 0.75 divided by 1.25. So you will get the answer 0.6. So ethane it is 0.6. Ethene it is 0.6. Here 0.4. So in the question they are asking about ethane. So ethane, what it is? 0.4, right? Right. So this is 0.4, which is 0.4. Ethane, C2H6, it is ethane 0.4 and ethene 0.6. So in the question, ethane only they are asking, no? This is 0.4. So the next question, Wood's metal contain 50% of bismuth and 25% of lead, 12.5% of tin and 12.5% of cadmium by mass. What is the mole fraction of tin? So here atomic mass also they have given each metal. So here total mass percentage. So total mass percentage, it is 100, right? So in that bismuth, tin, lead and cadmium, let us identify the number of moles. Right now here bismuth it is actually 50%, right? And lead, Pb, no, lead it is Pb it is actually 25%. This is bismuth, Bi, right? Now and the same way tin and lead. So tin it is stannous, it is 12.5%, and it is cadmium Cd, it is 12.5%. So each one percentage we can convert into a grams as the same. Right now here molar form, actually atomic mass they have given, no? So atomic mass how much? Bismuth they mentioned, it is in the question only they mentioned. So this is 209 gram per mole. Right now here 207 gram per mole, which is 207 plumbum, that is lead. And stannous, tin, it is 119 gram per mole. Right now the same way cadmium 112 gram per mole. So atomic mass of each and given mass. So directly we can identify the number of moles of each. So number of moles of bismuth, lead, tin and cadmium. So N of Bi. So N of Bi given mass by molar mass. So given mass, what it is? 50 gram. We can convert a percentage into grams, right? So molar mass 209 gram per mole. So how much percentage you are getting? You are getting around 0.2392 mole. This is mole. Right, now the same way, bismuth, next one lead, moles of lead, PB. So the same way here, 25 divided by 207, right? 207 gram per mole, right? This is gram. So when you cancel each, so you will get how much? 0.1208. This is mole, right? Mole. Bismuth one and lead and tin. That is that they are asking. No? So we need that one for mole fraction. Mole of what it is? Number of moles of P lead tin. Sn. Sn. This is 12.5 divided by 119 gram per mole. So this is gram. Right now here, what is the answer you will be getting? You will be getting around 0.1050 you will be getting, right? That is mole for 10. And the next one, what it is? Cadmium, N of CD. So this is actually the same, 12.5 divided by 112 gram per mole. So this is also gram. So you will be getting around how much? 0.1116 mole. So this is actually cadmium, and this is stannous, that is tin, and this is plumbum, and this is bismuth. So total moles, let us find total moles of all the metals. So total moles equal to, that is bismuth 0.2392 plus 0.1208 plus 0.1050 plus 0. What it is? 1116. So totally you will be getting how much? 0.5776 mole. Right, now mole fraction of tin. That is the question they are asking. No, mole fraction of tin. Sn. So you will get what it is. That is moles of tin. Moles of Sn divided by total moles. So each one fractions you will get. That is what. Okay. Now moles of tin, how much? 0.1050, right? Divided by total moles, it is 0.5776 mole. Both are mole only. So you will get around how much? You will get 0.1821. Is that mole fraction of tin? So everything you will get actually combined together, you will get the answer 1 only. But in this question, according to Narendra Avasthi sir's question, the option answer, it is 0.176 mole. I mean mole fraction it has got. But generally, this is the correct option. This is the correct answer actually. So which is nearer to that, we can take it. So when you calculate, you will get this only, right? So when you calculate, you will get this only. See, 0. Here. Option actually 0.1821 as that mole fraction, right? But here, which is nearer to that 176, is that according to this question, according to that book, this is the correct option actually. Exact answer, it is 0.1821 only is the correct option. I hope you got the clarity. How do we identify the mole fraction? And this is only the exact answer. Come on, let's go to the next question. The next question, the density of 56% by mass aqueous solution of 1 propanol CH3 CH2 CH2OH is 0.8975 gram per centimeter cube. What is the mole fraction of 1 propanol? See, this is very simple. Come on, let us identify mass. How much they have given? 56% by mass. Okay, mass of 1 propanol. So mass of 1 propanol, it is 56%. Now we convert into gram only. 56 gram by mass, right? Okay. Now next to one total mass, it is actually 100 gram. Total mass, that is 100 gram. So mass of water. So they added what? Aqueous solution. So definitely added water. So mass of water. How much it is actually? 100 minus 56. Here 44 gram, right? So mass of 1 propanol, it is 56. Mass of water, it is 44 grams. So you will get 100. So molar mass of 1 propanol. Molar mass of 1 propanol. So molar mass of 1 propanol, it is actually here CH3, CH2, CH2OH, right? So how much altogether when you calculate it? Here 60 gram per mole. Right, now here water molar mass of water. how much? This is, you know very well, universal dialog. It is 18 gram per mole. Right. Now, moles of one propanol. So, number of moles of one propanol. Right. So, this is given mass by molar mass. Right now, here 56 gram divided by 60 gram per mole. Right now, here the answer it is 0.932 mole. I hope you got that clarity. How do we identify? Now, moles of water, the same way, number of moles of water. The same. Here 44 now, 44 gram. We just found, right. Divided by 18 gram per mole. So, when you calculate it, you will get what it is, 2.442 mole. Right now, total moles combined. Because mole fraction, no. Total moles. Mole fraction, always you just add that moles. Okay, then you can identify that mole fraction formula. Total moles, how much? Here 0.932 plus 2.442. So combined together, you will get how much? 3.374. Combined together, it is mole. Right now, here mole fraction of one propanol. Mole fraction. It is chi, right? Mole fraction of one propanol. Right? So this is chi of one propanol. I just mentioned. So here moles of propanol, number of moles of propanol divided by total moles. So you will apply the value here. So this is 0.932 divided by 3.374. So you will get the answer 0.276 as that. No unit for mole fraction, propanol. So mole fraction of one propanol, it is 0.276. Remaining water. So when you add both compound, you will get 1 mole fraction. And the question density they mentioned what it is. And the question here density here actually what it is 0.8. Yeah, here 0.897 gram per centimeter cube they mentioned, actually, which is not required to find the mole fraction. Right, mole fraction what we required, number of moles we required, then finally we can identify which is that main, that is specific to mole divided by total mole. So you will get that mole fraction of that compound what they are asking. But here they have given what it is, density. So density which is necessary to calculate molarity and molality, not for mole fraction. So which is not required here, we no need to consider, just we get that confusion, for that is the reason. Right now, which is the correct option we found here, 0.276. So option D is the correct option. I hope you got the clarity. How do we identify mole fraction? It is very easiest point. Okay, but they will confuse, for that is the reason, because easiest to know. So we'll get that idea. When we confuse, no, definitely we'll get best idea. So we have to practice more and more. Concept, it is fine. Okay, concept you hold it tightly, but you have to do number of practice sum, so that it will be easy for you to identify clearly. Right, come on, let us go to the next question. The next question, what is the molarity of sulfate SO4 2- ion in aqueous solution that contain 34.2 ppm parts per million of aluminum sulfate? Assume complete dissociation and density of solution, it is 1 gram per ml. Right now here, molarity, what it is? Molarity of aluminum sulfate, Al2SO4 thrice equal to 34.2 ppm parts per million they mentioned. Okay, now here aluminum sulfate ion in aqueous solution contain, right? Here we have to find out that gram, that is given mass, we have to identify. Generally ppm equal to milligram per liter. So milligram per liter. So aluminum sulfate, that is contained aqueous solution that contain 34.2 ppm of aluminum sulfate. So that is the way we can identify. So ppm, that is equal to milligram per liter. So milligram per liter means 34.2. We convert into 0.0342 gram. Can we convert in that way? Gram per liter. So this is milligram. We just converted into gram directly. Right now here density of water, it is pure density of water, it is 1 gram per ml only. So here also they mentioned density equal to 1 gram per ml. Right. Mass by volume, right? So 1 gram per ml. So number of moles of aluminum sulfate. Number of moles of aluminum sulfate, Al2SO4 thrice equal to given mass by molar mass. So given mass, this is only given mass, right? So we just converted ppm converted into grams. Right now here, can we apply the value here? Molar mass of Al2SO4, it is around, when you calculate now, here you will get 342.14 gram per mole. Right, now can we apply the value here? 0.0342 gram divided by 342.14 gram per mole. So gram will be cancelled. So you will get 10 to the power of minus 4 mole. So here number of moles of Al2SO4. So number of moles of Al2SO4 thrice equal to 10 to the power of minus 4 mole. I hope you got that idea. Now molarity of sulfate ion we have to identify, right? Molarity of sulfate ion. So molarity of sulfate ion SO4 2 minus. So this is ions now. Right now Al2SO4, when you separate it, Al2SO4 thrice, right? Al2SO4 thrice, when we separate 2Al3 plus 3SO4 2 minus. That is the way we separate it now. So that means here molarity of SO4 2 minus ion. Molarity of SO4 2 minus. So you will get 3, right? So here 3 moles now. 3 into number of moles of Al2SO4 thrice. So number of moles of Al2SO4 thrice, how much we got it? Number of moles of Al2SO4 thrice 10 to the power of minus 4. Right now here, according to the balanced, it is 3 SO4 2 minus, right? So here that means 3 into 10 to the power of minus 4. Right. So molarity of SO4 2 minus, it is 3 into 10 to the power of minus 4. Okay. So molarity of SO4 2 minus ion in aqueous solution, that is 3 into 10 to the power of minus 4 m. Right now here, which is the correct option? Option A is the correct option. I hope you got the clarity. How do we get that? See, this question basically about the density and the ppm, how to convert. This is very important. This point you please note down. How do we identify the ppm conversion into that gram? So ppm equal to milligram per liter. So that is what we have converted this, right? I hope you got the clarity about this question. Come on, let's go to the next question. The next question, the relation between molarity and molality is given by density of solution, gram per ml, m1 molar mass of solute. See here, this question is basically what it is, concept oriented question. We have to bring that formula. How do we identify that molarity and molality and the density which is related to that molarity and molality? Molar mass. How do we correlate with that formula? That is what the question asked. Come on, let us check with that. So generally molarity, it is actually number of moles of solute divided by volume of solution in liter, right? The same way molality, it is number of moles of solute divided by solvent in kg. So molarity we considered for the concentration of the solution, and the same way molality we always remember that what it is, kg, that means solid, for calculating about that solid mass in kilogram. Right now, come on, let me write that formula for you. So molarity equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter. Right. The same way molality equal to number of moles of solute divided by solvent in kg. Solvent in kg. Right, mass related. Okay, now given mass, how to identify? So number of moles of solute, it is actually what it is? Number of moles of solute. So this is a small n. So we can take it out. This is capital M. Molar mass, capital M1 they mentioned, So this is given mass, number of moles of solute, it is n, and mass of solute, given mass or mass of solute. So mass of solute, how do we identify? So number of moles into what it is? Molar mass here, M1, right? So here molar mass only, this is. So number of moles. So this is molar mass. So molar mass into number of moles, you will get a given mass, right? Now total mass of the solution. Total mass of the solution. Total mass of the solution, it is volume into density. Please note down all these points, because when we apply to the questions, then only we will identify. This is simply if we learn concept only, it will not be using. Only when you apply only it will be useful. Right now, volume, it is 1000 ml into density. Density, it is actually one, for water density, it is 1 gram per ml. So this is a rho. Rho only is the density. So find the mass of the solvent. Now, how to identify the mass of the solvent? Find the mass. These are all the concept what I'm giving for you. Find the mass of the solvent. Solvent. So this is total mass of the solution. Total mass of the solution. Solution minus mass of the solute. Mass of the solute. Right now, I hope you got the clarity. Now, mass of the solvent, how to write here mass of the solvent? Here, 1000 rho minus capital M, M1. So, M1, it is molar mass. Capital M, it is a given mass. Right. So, this is the way mass of the solvent we can identify. Right now, here molarity, M. Molality. Molarity, you got it. Molality. Molality. Molality equal to moles of solute. Moles of solute divided by mass of solvent. Mass of solvent in kg. Already I just mentioned into 1000. Kg only 1000, right? Now here small m. Small m is the symbol. So how can you bring it? Capital M, that is moles divided by 1000 rho. Density minus capital M, that is M1, molar mass. Here given mass, that is moles of the solute, right? Divided by 1000 rho. Density minus here mass of the solvent and molar mass. Right now, here they are asking that question according to that molality, no? So molality equal to 1000 m, capital M divided by 1000 rho minus capital M, M1. So this is the correct option. See the way they are asking question. Really, it is marvelous, amazing to bring the answers and practice the questions. Really, you will get the fruitful effect of your concept, and your way of thinking and your way of learning. Thinking level will be higher and higher. I hope you got the clarity. Right, come on, let us check the option according to this. So molarity, you know, molality, you know, mole concept, related density and molar mass, everything. So which is the correct option? Molality only they are molality only they are asking. No, so molality M equal to 1000 m. This is a given mass. This capital M, it has mentioned a given mass. 1000 rho minus rho, it is density, minus given mass into molar mass. So option D is the correct option. Option D is the correct option. Right? Option D is the correct option. Yes, this is the correct option. All right. Hope you got the clarity. Come on, let's go to the next question. It is going around the neck, but still it is interesting. The next question, molality of a solution of a liquid. Molar mass, it is 50. In aqueous solution is 9 and 10 respectively. What is the density of the solution? Really, last question and this question we can correlate with that formula so that it will be easy for us. Density, you know very well. Density means mass by volume. Okay. Density equal to mass by volume, right? Molarity of respectively they mention a molarity of the solution 9 and 10 respectively. Molarity and molality, right? Molarity, it is 9 gram per liter, mole per liter, sorry, it is 9 mole per liter. And the same way here 10. Here also they mention mole per kilogram, mole per kilogram. Right, now here molar mass of the solution, it is molar mass of the solute, right? Molar mass of the solute. Of course, it will be molar mass of the solute, right? So molar mass of the solute, it is 50 gram per mole. Right, now relation between molality, density. The relation between molarity and density. So I just put it that symbol. Molarity capital M, molality small m, and rho, it is density. So this is capital M, this is small m, and density, it is rho. Right, got it? Now here small m equal to 1000 capital M, that is given mass, divided by 1000 rho density minus small m, that is capital M, and M1, that is a solute given mass into molar mass. That is okay. So this is what the last question we found now. So this is what last question we found, right? So come on, let us apply the value. So here density D, right? Here rho we can convert into density. So rearranging the formula. So density D is equal to capital M by small m. Okay. Plus here capital M into mass of that solute. Solute. Right. Divided by 1000. The same formula only I just mentioned here. Right. Capital M molarity and molarity. Plus this is what it is, molar mass into mass of the solute divided by 1000. I hope you got that idea. Yes, of course. Right now, D equal to molarity, it is 9. Molarity, it is 10. Plus, here what it is? Molarity, that is 9. Molar mass, it is 9 into 50. Solute, molar mass of the solute divided by 1000. 1000, right? So now, can you calculate this? When you calculate it, you will get 9 by 10 equal to 0.9 molarity. Molarity, right? Molality, when you calculate it, so this is capital M. Small m, it is how much? This molality, when you are calculating, this is 450, right? 450. I hope you got an idea. 450 by 1000. This one 450 by 1000. This is when you calculate these both, you will get 0.45 molality. Molality. Right. Now next one, both you have to add. So this actually I have separated this one. We are getting 0.9. This one we are getting 0.45. Both I am adding this. So capital M and small m, that is molarity and molality. 0.9 plus 0.45. So you will get what it is, 1.35 gram per ml. That is density, we got it. I hope you got the clarity. Why density we got it? Because the question I have, the formula I have arranged in this way, right? See here, the formula I have arranged in this way. So now you see this formula, D equal to this formula I have arranged in this. Right? See, D equal to capital M by small m, that is molarity by molality plus molar mass and mass of that solute divided by 1000. Right? I hope you got the clarity. So density of that solution only they are asking. So density of the solution D, that is density of the solution, D equal to 1.35 gram per ml. Right? I hope you got the clarity. This is basically last previous question. No, the same idea, we just bring it. Okay. So which is the correct option? Option D is the correct option. Here cc, cubic centimeter. Here also volume, gram per liter, cubic centimeter. Right? I hope you got the clarity. Yes, come on, let's go to the next question. The next question, an aqueous solution of ethanol has density 1.025 gram per ml and it has 2 m molarity. What is the molarity of the solution? See, all these questions basically upon molarity, molality and density, all these things together. So, okay, now density of the solution, density of the solution. Solution 1.025 gram per ml. Right now here, mass of the solution. Here, mass of the solution. Mass of the solution. Mass of the solution, how much? Here they mention. Actually, we can identify density equal to mass by volume. So mass of the solution, density into volume, right? So volume of the solution. Volume of the solution generally what it is? 1 liter. So that is volume into density. No. So volume it is 1000 ml. Right. Density 1.025 gram per ml. So ml will be cancelled. ml will be cancelled. So you will get mass of the solution gram. How much it is? 1025 gram. It is a whole number. You got it right. Now, next one, mass of the ethanol. Mass of ethanol. Mass of ethanol. So mass of ethanol, it is molar mass of ethanol, you know very well. And mass of ethanol, how to identify? Moles into molar mass. That is what previous question and concept way, 8th question also we have mentioned. It is moles into molar mass. That we will get given mass. Here, this is a given mass. Given mass. So given mass, how do we calculate? Moles into molar mass, we will get that what it is, given mass. So moles, how much it is actually? Here 2m they mention. No, that is 2m moles. So 2 into 2 moles of molarity, right? Moles into molar mass of ethanol. Molar mass of ethanol, CH3. CH2OH. So how much it is? 46 gram per mole. I hope you got that idea. Now, what is the answer? You will be getting 92 grams. So given mass of ethanol, it is 92 gram. And molar mass of ethanol, it is 46. And mass of water. Now we have to identify what it is. Mass of water, right? Mass of water. Why we have to find out the mass of water? Because molality. Molality, it is number of moles of solute divided by solvent in kg, right? So that means here, what it is, mass of mass of the solution, it is 1025, and here mass of the ethanol, it is 92. So you have to minus that. 1025 minus 92 gram. This is also gram, right? So you will get mass of the water. So mass of the water 0.933 kg. Right now here it's gram only. I just mentioned kg. Here, what is the answer you will be getting when you calculate it? 933 gram only you will be getting, right? So I just converted into kg because kg only we will apply that. So molality equal to moles divided by solvent in kg. Solvent in kg. So 2 moles divided by solvent in kg, 0.933 kg. Right. Now here 2.143, what it is? Mole per kg. Mole per kg. Right now here molality of 2m aqua solution. Molality of, this is small m, please remember. Molality of 2m aqua solution. Aqua solution ethanol, no? Ethanol. It is 2.143 mole per kg. I hope you got the clarity. Come on, let's find out the answer. So 2.143. Yes, that is the answer we found, right? Yes, 2.143. So the option, it is B, is the correct option. I hope you got the clarity of all these questions. Okay, come on, let us go to the next question in our next video. And thank you for watching.